Hi guys, today we're going to be solving a contest math problem. What is the last digit of 27 to the 2019th power? Okay, so we see there's a year. We see there's like some sort of arbitrary number. And whenever you see something like that, it's always a good idea to start with smaller cases than to generalize. In fact, in math as a whole, you'll see that generalization is a very big topic. So, let's try it. Let's try smaller powers of 27. Let's see, so we get 27 to the 0. That's simply going to be, the last is going to be 1. 27 to the 1, the last is going to be 7, obviously. Next up, 27 squared, which is going to be 27 times 27. Okay, 7 times 7, that's 49. And then you have to keep that right here. And then now, 2 times 7, that's going to be 14, so we get 189. Next up, 20 times, yeah, so 20 times 7, it's going to be a 4 right here. And then it's going to be a 5, and then it's going to be 9. That just drops down to 7. There we go. So the last digit is 9. So 27 squared is 9. Now, let's go ahead and, we could try and calculate 27 cubed, but it's honestly going to be very tedious, and you know, it's going to be something like 19683. Okay, the last digit is 3, but it's pretty monstrous. So if you keep on multiplying by 27, you obviously won't get to 2019 anytime soon, right? So this is not, it's not a good strategy, but let's see what we can glean from this. Well, notice that this 9 right here, where did it come from? Well, it came from up here, right? It didn't get added with anything. And that 9 came from 7 times 7. It's the last digit of 7 times 7. The 40 got added with something, but the 9, the last digit, that stayed the same. And that's actually a key observation, right? So now we can reframe this problem as 7 to the 2019. Okay? So let's see. Now we sort of have it easier. Another thing is, you don't have to multiply the entire thing by 27. In fact, it's enough to simply multiply this 1 times 7, and then multiply the 7 times 7, that's going to be 49, and then you keep the 9, you multiply that 9 times 7, 63, and you keep the 3, right? So multiplying by 7 again, we get that 7 to the 4th power, at least the last digit, is simply going to be 1. So we're multiplying by 7, and then we looped back to 1. What does that mean? And in fact, I'll write the 7 to the 4th power up here. Well, this means something special. That means it loops back around, so we can go ahead and infer that 7 to the 5th power is, it corresponds to the number 7. Okay, and we don't even have to multiply by 7. We don't have to do that work because we already did it here. And then subsequently, 7 to the 6th power goes to be 9, and then 7 to the 7th power is 3. Okay, so notice 0 and 4, they're all multiples of 4. 1 and 5, they're all multiples of 4 plus 1. 2 and 6, multiples of 4 plus 2, and so on. And in fact, this rule keeps on going. So we could say that 7 to the 4n corresponds with 1, the last digit. 7 to the 4n plus 1 corresponds with 7. 7 to the 4n plus 2 corresponds with 9. And then 7 to the 4n plus 3 corresponds with 3. Okay, so now we have these rules. So how do we know which one is 27? So we have 2019. Which one is 2019? Is it a multiple of 4, 4n plus 1, 4 plus 2, or what? Well, we know it's not a multiple of 4 because it's odd. And we know it's not a multiple of 4n plus 2 because it's even. So let's try and see if it's a multiple of 4n plus 3. And then obviously, one other thing, n has to be an integer for this to work, since we're only dealing with integer powers right now. In fact, we're not even dealing with negative powers, so, but n has to be positive integer, right? Or it could be 0. First thing we're going to do, we're going to divide by 4, so we get 2019 to the 4th, over 4 is n plus 3/4. What does it say? Well, this is 2019 divided by 4. This is just some integer, and this right here, this 3/4, the 3 is actually a remainder. If you remember from long division, this 3/4, the 3 is called the remainder, and it's what's left over from the division. So, we know that 2019 is of the form 4n plus 3 if the remainder is, in fact, 3. So let's go ahead and do that. 2019. First of all, 20, we can do a 5 right there. Oops. And we get a 0. We can drag down the 19, and that's going to be a 4. So that's going to be 16, and then 3. So, we know that what is n is 504, obviously. But, more importantly, we see that it's 504 times 3/4, right? So this is actually true. When you divide 2019 by 4, the remainder is actually 3, and that means 2019 is of the form 4n plus 3, where n is an integer. We sort of lucked out, and you don't have to check 4n plus 1. We know 3 is right, so this is it. It's our correspondence, and that means that the last digit is in fact going to be 3. So we can write that down and then be happy. Thanks for watching.